Hello everyone. Today we've got a super exciting topic for you, which is retrieval augmented generation, that is also known as RAG. This is a game changer of AI, and without wasting much time, I would like to hand it over to Ronak for the further discussion.
So yeah, before going into the details about RAG, we'll try to understand a bit about why RAG is important. That is because of some of the limitations of LLM, what uh, we see generally. So first point is about knowledge cutoff or fixed knowledge base. So as you might be aware, the LLM needs to be trained, and those training happens on large amount of data, which takes longer time. And doing this complete training and releasing to the end user, it takes several months. So, for example, any LLM is released now, uh, it may happen that the data which was used to train the LLM was 1 year back. So LLM has no knowledge about what happened in this last year. So that is what is called as a knowledge cutoff. So LLM will not be able to answer uh, with the 100% accuracy about recent event which has occurred after the training of the LLM. So this is one of the limitation. Second one is about hallucination. So hallucination in terms of AI is like model will fabricate possible sounding answers, but it is not actual facts. Uh, so it seems like it is correct basically, but it is not the truth. That may occur, I mean, based on different reasons, like how the model is trained, how model is working, and so on. Just to give an example of hallucination. So if someone asks me like which planet has the highest number of moons, so based on my knowledge, maybe I say that I like yeah Jupiter has the highest number of moons, but which might not be correct. So cause the answer is given by my knowledge, whatever I remember maybe, and so on. But if like someone reads through the actual source, they might know, okay, maybe Saturn has the highest number of moons. So this is what is called hallucination in terms of AI. Third point is about inefficiency for the domain specific queries. So for example, like we know that models are trained based on the publicly available data, right? So whatever data are not available to the public, model will not be knowing that. For example, some of the ISO standard relevant informations or some of the company specific informations like that, which are proprietary data. So model will not be trained on that. And if someone asks the query based on that, model will not be able to provide those answers. Right. So these are some of the limitations uh, we see the LLM has. So that is where the RAG retrieval augmented generation is helpful. We'll see that how it is helpful. So first of all, let's understand what is RAG. So RAG is already you have seen the full form is a retrieval augmented generation. So it is a technique used in natural language processing, which combines the use of generative models like LLM with information retrieval. So again, we will see in deep like what is information retrieval. But yeah, it combines this technique so that performance of the LLM can be enhanced. So in simple word, if I explain, so uh, as we already know, like generative models generates the output right in the textual language. So the generated output is augmented based on the retrieved data. So augmented, in other words, is the enhanced, right? So enhanced based on the retrieved data. Yeah, can go next. So how RAG works? As we have seen, like RAG has three main terms, like in the name itself, the retrieval, augmented generation, and that is how the RAG works. So first, if you understand about the retrieval, so retrieval is about searching the relevant information from the external source. So here external source is any data other than the LLM has or the model has. So this data could be like, yeah, anywhere open in the internet or any documents uh, or any database and so on. Uh, and augmentation is this retrieved document are added together with the query asked by the user. So generally like whatever query is given, that is augmented with this retrieved data, and that is provided to the LLM. So that is what augmentation is. And generation as already, I mean, as you might already know, like it is just simple generation. So generation is generating the output based on the LLM models. So yeah, that is how RAG works basically. Then in the next slide, we will go into the actual workflow of RAG, how it would work. Before going there, uh, let's see normal LLM query workflow, how it works, right? So uh, any user wants to get anything from the LLM, so they create the query, which we are calling as a user query, and it is provided to the LLM. Generally, like if you are using the Chat GPT or Chat Gemini and so on, so you write your query into the chat box, then LLM gets as input, and then LLM will provide the output, the response from that, right? So this is how general query workflow works. So now how RAG can be combined with this is shown here. So as we seen earlier, like uh, user query is augmented with the RAG. So how it works is, uh, as you can see, the user query is provided to the retriever, which is shown in the middle part of the slide, and the retriever has access to the external data like the internet, different document types, files, and so on, or any databases where the data is stored. So what uh, retrieval will be able to do is it will able to retrieve the relevant data based on the user query, and then combining normal user query and the retrieved data, the LLM query would be created, which is shown in the blue hexagon above. So that is the actual query, what is or what will be given to the LLM instead of the actual user query, how we seen earlier. And yeah, then everything works normally. Like once LLM query is provided to the LLM will be able to pass those inputs, and it will be able to generate the relevant output, the response based on that. And yeah, user will get the output. So this is how the workflow with RAG works. Go next. Okay. So as we have seen, there were main three part of RAG, like retrieval, augmentation, and generation. So this is how it could be mapped to the workflow. Like if we start from the right side, so generation is normal generation, which are done by the LLM. Augmentation is done uh, with the user query and data which are retrieved by the retriever. So augmentation is in the LLM query, and the retrieval itself is done by the retriever. So as we can see from the workflow, the main component of RAG is retriever, which does the main work, right? Because it uh, fetches the data from so many sources and so on. So then we will try to get more understanding about retriever, how it works. Okay, so yeah, as we can see here, uh, we have given some more detail about how retriever works actually. So some of the elements are same as we have seen earlier, like user query is there, then user query is given to the retriever, uh, so that retriever can fetch the relevant data uh, relevant to the query, right? But how does it do that? So generally, as uh, you might be aware that our queries are text, uh, just normal text, right? It is written in normal sentences. So it is understood by human. We write some paragraph, right, with the sentence and so on. So it is understood by us. But how uh, retriever understands it, uh, or how model understands it, or how any program understands it, right? Because it is a normal English language or any other language text. So what retriever does is retriever converts this text data into embedding. I will explain what is embedding in a while. So retriever converts this text user query into embedding. What I'm calling here is a query embedding, and that is used to retrieve the data. Now, what embedding is? So embedding is nothing but uh, it is a vector or array of numbers of specified length. So as you might be aware of matrix in the mathematical terms or a vector. So the embedding is nothing but one dimensional array of specific length. Now how the embedding is created, right? So there are specific models, the embedding models, what we call generally. So what the does is they take textual input and it converts this input to the this one dimensional array or vector. That is what we call as embedding. So there are certain complex algorithm and logic happening behind that. We'll not go into that, but that is how embedding is generated. And now, as it is represented based on these numbers, generally machine understands these number things, mathematical formulas, right? Because everything is implemented based on these mathematical algorithms. So based on this query embedding, there are algorithm which can find the relevant source of data from the vector database. Now here again, vector database also is a new term in terms of you might have heard about normal database. So database is where we store any information, right? But vector database, as I explained, like query embedding is kind of vector. So vector database is where we store different vectors. So there are different vectors of data stored, and that data are retrieved based on the matching query embedding. And that retrieved data is used by the retriever, and it will be used to create the LLM query along with user query. Okay, so as I explained, vector database stores different vector datas which are created based on the uh, different source of data. But now how this vector data are stored into the vector database, right? Or how it is created. We'll have a short look into that. So as we seen in high level workflow, we have different data source, like data could come from different files, from the internet or any other company database and so on. Generally, those data are also textual data, like in the files we have textual data, or in the internet and so on. Everything is textual data, how the human understands it. Uh, but as we seen, like there are different mathematical algorithm and formulas which is involved in the retriever and also in the searching of the relevant data. It doesn't work based on the normal text. So what also we have to do here is here also we use the embedding model and convert this textual data into embedding, and we store this into vector database. So in the vector database, there'll be different chunks of information stored, and along with those chunks, relevant uh, embedding values also will be stored. And yeah, there will be like a number of chunks created based on different, or how many data we have, or how much data we have. Uh, why the what is chunk now, right? Like, so as we see, like generally whatever the files we have or documents we have, it may have many number of pages, 50, 100 and so on, right? Many number of pages. We can't store everything together in vector database, because if we calculate embedding based on this large amount of text, then there is very much chance that this embedding will be similar to many queries. And if we use this large amount of data as a retrieved data, then our retrieved data won't be good. So what we do is we divide this input data into small chunks which are having very relevant informations. For example, you can consider as paragraphs. Like if I have 100 page of book, and in one page there are 5 paragraphs, then I divide this all the text into paragraphs, and I store one paragraphs as one chunk. And the embedding is calculated for this one paragraphs. So that when we use this search algorithm in the retrieval based on our query embedding, we will be able to find uh, relevant paragraphs based on the embeddings, and that will be used by retriever. So this is how in general retriever works. Again, there are many more technical details like how we do the chunking. There are different several methods of that. How we do the search. Again, there are different search algorithms and so on that we might see in later videos. But just to get short overview, this is how retriever works in general. Yeah, as we seen the details about how RIG works and different components and so on. So now Riva will explain about further things like its advantages and so on.
Yes, thank you, Ronak, for the explanation about the complete overview of the RAG and the advantages. So, while speaking about the different components, we got to know and we understood that RAG basically is something which is the traditional LLM models which are available. They are trained up to certain limit or certain time of data, then to access to make it more reliable on the current data. So RAG is something which comes into picture as it has access to the up to date information. So whatever the data source that we give, it is totally dependent on that. The next one that we can see is less hallucination and improved accuracy and factuality. So this is where like hallucination, as you explained, the LLM trying to give some answers for the question that we have, irrespective of the fact that it may be factually correct or not. It may seem like okay, it is correct, but it may not be 100% that LLM is always giving us factually correct answer. So this is where when we use RAG, we have our data source or the using the external data source, we augment the data on the for the LLM so that it can generate more factual answers and the accuracy of the response automatically increases. And next we have the advantage is domain specific knowledge integration without training. So as we know that traditional LLM, if we try to train, if we are looking for training an LLM, it is a huge cost. There is a huge time consumption, and also it is a very costly to train the method, and you require lots of resources and different kinds of things that you have to think while if you want to go for a training for LLM. Also you need lot of data and this kind of thing. So this is where if you have less data and you want your LLM to work more on the domain specific or or maybe you want to align your LLM to the domain specific knowledge, then the RAG is one of the suitable options. Next we have is knowledge scalability and flexibility. As we understood, or as we get to know that it is easy to update the information. It is not like the traditional LLM that you have trained your model at or you have trained a model till a particular data, and now you will have to work with that itself. So whenever there is a need for upgrade in the information, so you can upgrade the information in the knowledge base or the vector database, as we saw in the implementation. As in one of the component, we can update the information, we can update the documents that we are going to give as an input for the vector database for the LLM. The information that we want to augment to the LLM, we can just simply upgrade those documents and upload it again, and then RAG simply or the LLM simply refers to those documents and start generating the response in that way. And next, as I already talked about this point, when we talk about the training point, so cheaper and faster implementation. There is no need for spending so much huge amount of time as well as huge amount of money for training, for going for the researching for the resources, and then using GPUs and all of this for the training, as RAG is a solution which is pretty much easy and optimal solution for the uh, if we want to work in align to our data with the LLMs. So these were the advantages of the RAG, but as we know, Everything has a positive side, then there are also some negative sides to it, or maybe some limitations of the RAG, where RAG would not maybe RAG would not be fully able to achieve the goal. So yeah, the first one that we can see is retrieval quality. Retrieval quality basically, uh, as we understood from the explanation, RAG is totally dependent on the input data that we give to it. So if we give some random, some garbage data, then the quality of the output will automatically lead, or it will automatically decrease, as it is heavily now focused on the augmented data for responding, as the LLM is now heavily relying on the augmented data. The next one is chunking strategy. So chunking strategy is also important, splitting the document in proper way. Like we need to split the document in the proper sections, or we can say subsections. If we are splitting the document randomly from some line, for example, if you take from one section, if you take some 5 lines of that paragraph, and then some other 5 lines are present in some other chunk, then this may lead to the context, like there would not be a complete context available for the LLM to understand, and which is where the LLM may not be able to generate the good answer for it. Uh, the next point that we have is latency. Latency is basically, as we understood, that every time an LLM has to respond to some of the query, then it has to go, the retriever has to fetch for the documents in the database, and then it has to give some answer. It has to augment that information, and then it has to give that answer to the user. So this is where latency, it would increase, it would increase a bit of the time in of the response. Also, we have some of the other limitations like context limit length. So LLMs are, generally we see the LLMs have restrictions on the input context, or on the input length or context length. So uh, this is where the retrieve if the retrieve context is too long, then along with the query, so our query and the retrieve context, if the retrieve context is too long, this can be a limitation for the LLM. Maybe an LLM which does not have a high context window, it would not be able to process the information. So this is where the context length limit is also comes as a limitation for the RAG. The next point that we have is lack of deep understanding. So lack of deep understanding. So this is where, if for example in our data, in our document itself, there are some of the things, maybe there are some sentences which are speaking about some one of the thing, and there are some of the sentences which are saying something contradicting to to that information itself. Then it becomes difficult for the LLM to decide, because the data, everything that we are going to give is in the document itself, and if such kind of information is available in the document, some contradicting information is available, then it becomes difficult for the LLM, what information should it consider while while processing the response. So this is where lack of deep understanding is one of the limitations. And next one is the dependencies on the good embeddings. So embeddings is, as we see, embeddings is also one of the most important part of the this whole workflow or RAG workflow. So if the embeddings are not calculated properly, as embeddings are totally the query embeddings, the embeddings are created for the query, and if those are not matched properly semantically in our database, then it may lead to retrieval of wrong information, and this retrieval of wrong information can further lead to the wrong responses, so generation of wrong responses. So this is where the dependent, like good embeddings, good quality of embeddings are also important for the RAG. uh
So just to
any
add
Yeah.
one point from my side. So overall, like whatever limitations we seen, some of them are not like limitations itself. Like okay, you cannot do anything. but some of the points are to keep in mind, like when you implement the RAG, like okay, there are context limit you have to keep in mind, so you don't give so much large queries to the LLM, and also yeah, use the good embedding model and so on. So it's not like okay, you can, these are the limitations, so you can not use or improve here, but just to keep these points in mind, like okay, you have to use good embedding models, or you have to chunk your data properly and so on. So these are some of the points also to keep in mind when using the RAG.
So then we go on next, real world use cases of RAG. So for this question, I would like to ask our participants, based on the understanding of the whole RAG workflow, and also we looked at the advantages and limitations of the RAG. Uh, what do you think? What could be the real world use cases for RAG?
Mhm. Okay, so as I understood the RAG, so if I compared with the real world use cases or whatever I have seen, so all kinds of chatbots we see nowadays, for example, any bank chatbot we are seeing, that we are asking that what is the policy for this particular thing, then it is responding. So I believe they are using the RAG because they have their own database, and from there the whatever the specific question I asked, it will retrieve that information and use the LLM to generate the response back to me. So I think that is one of the use case I see where RAG is used. So yeah, that similar to that, if we see in companies where internal portals are there and you ask something, then for example, what could be the next month leaves available? So in that case, normal chat GPT or any Gemini model, when you ask, it doesn't have the this information. So that's where internal companies will have such portal there. If you ask, and it will respond. So there also, I think RAG is used.
Those were some really good use cases.
So another good case would be like um, while generally it can be used anywhere actually, but basically what I understood was it is kind of giving a context, a basic dictionary of information to the LLM. Like some, for example, I am from electronics branch, and sometimes you give a question to normal chat GPT, Gemini, or any LLM, it cannot solve it. It just fails to understand what's the context behind it. And there we can use a specific, we can use this RAG, like giving it specific formulas, books, documentation, data sheets, based on which it can, solve the problems and design the circuits and anything. So I think, yeah, that can be a case for RAG, use case for RAG.
Okay. Another yeah, use case for our uh, things could be like the automotive domain, right? Like when we work with the software development or system development with the automotive, uh, in the complete this development cycle, generally all the data what we used for the projects are confidential. It is not available to outside world. So of course the LLM also won't have those knowledge for most of the data. So we can use this in several stages of complete development life cycle in the automotive. For example, like in the code development, generally we see like we write so many of code manually and so on. Now there are several guidelines specified by company itself. Like okay, we have to write code this way using these formats, so and so and like that. Normal models will not be able to generate code directly using those guidelines because they might not be aware. So here also, for example, we can use RAG. So these guidelines are internal to the company, and those data could be used, and then more relevant answers could be generated with the same LLMs. Code was just for example, but I mean, yeah, this there are several ways this could be used in complete software development lifecycle or any product development lifecycle here.
So I have a question. Uh, how can we evaluate a RAG system or RAG system?
So for the evolution of RAG, uh, first of all, we have to define like what uh, parameters we have to evaluate or we want to evaluate. For example, like okay, we want to evaluate how good are the output from the LLM, or we want to evaluate how good our retriever is working, and so on, right? So there are several metrics available, and those metrics could be calculated based on several mathematical formulas, and those numbers would represent these things like how. So there are several metrics to show how good LLM output is there based on the RAG. There are several metrics to show how good is your retrieval data, and so on. So based on these numbers, you would be able to evaluate like how good these several components of complete workflow is working. One of such uh, mm, uh, metrics is defined by the RAGAS framework. So RAGAS framework again has several metrics to show different. Sorry, RAGAS framework has several metrics for the different components, as I said, using which we can yeah measure and evaluate the performance of complete RG system.
Um, all right, it's clear. All right.
So I have a question, which is how can you improve RAG performance?
So as we have seen uh, in the one of the previous discussion that there is this RAGAS framework, or at least one of the framework, which is called RAGAS, using which we can measure the performance of complete RG system or several components of RG system. Now, based on this metrics, we will be able to find which components or what part of the RAG is not working properly. For example, there are low scoring in the retrieval part. There are several metrics which measures the performance of the retrieval part. So then we know that okay, the retrieval part I have to improve because my retrieving is not good, and so on. But again, based on which part has the issue, we have to improve different things. Like just to take example of the retrieval. So if our retrieval is not good, there could be several problems. Like our searching mechanism is not working good, so that is not able to find our search the relevant context, or the chunking is not proper. Maybe whatever data we had, it was not chunked properly, so the searching is not able to find the relevant data from the database, and so on. So depends on like where uh, the problem is. There would be several possible solutions, and yeah, by fixing those, we can improve the performance of oral RAG.
Yes, thank you for the explanation. Understood.
All right. So that's a wrap up for our session, today's session on RAG. Feel free to put your questions or queries in the comment, and do like, follow, and subscribe to our page for more such informative videos on AI and different technical topics. Thank you.